Hello everyone. When gypsum is mentioned, many of you may first think of the plaster bandages used in orthopedics departments to immobilize fractures. Now, imagine this. What if a doctor used the quicklime we discussed in the previous lesson to fix a broken arm? Exactly. Your arm would be severely burned. Why is it that both are cementitious materials, yet doctors safely use gypsum but never lime? This brings us to the core question of today's lesson. Compared with lime, what unique characteristics and properties does gypsum possess? In this session, we will delve into building gypsum. To begin with, building gypsum, like lime, is an inorganic, non-hydraulic, cementitious material. The image on the left shows natural gypsum, while the one on the right shows gypsum powder. The commonly used natural gypsum is chemically composed of calcium sulfate dihydrate. Now, take a look at this stunning image. It shows the Naica Crystal Cave in Mexico, the largest natural crystal cave in the world. The massive, transparent columns you see are actually natural gypsum crystals that formed over millions of years. They developed through the slow dissolution and recrystallization of underground anhydrite during an extended cooling process. Standing before these crystals, some over 10 meters tall, humans appear remarkably small. The image gives us an intuitive appreciation of the extraordinary beauty of gypsum in nature. So, how is gypsum transformed into a civil engineering material? Its production process is actually quite straightforward. Natural gypsum dihydrate is calcined in a dry environment at about 107 degrees Celsius to 170 degrees Celsius. Within this temperature range, gypsum dihydrate loses part of its crystallization water, forming beta-type hemihydrate gypsum. After grinding, it becomes the building gypsum powder we commonly use. As for its appearance, pure gypsum is white. However, as shown in the image, naturally mined gypsum often contains impurities such as clay and organic matter, so it may appear gray, brown, or yellow. In addition to building gypsum, calcination at different temperatures can produce other types of gypsum products. For example, high-strength gypsum develops larger and denser crystals, giving it significantly higher strength than ordinary gypsum. There are also other forms such as soluble anhydrite and insoluble anhydrite. The gypsum we purchase is usually in powder form. So how do we use it? Add water. This process is quite remarkable. When hemihydrate gypsum powder is mixed with water, it initially forms a fluid suspension, similar to milk. As stirring continues, the hemihydrate gypsum rapidly absorbs water and undergoes a chemical reaction, reverting to gypsum dihydrate. Since gypsum dihydrate has low solubility, it quickly precipitates from the solution as crystals. As the slurry thickens, it takes on an ice cream-like consistency, and eventually the crystals interlock to form a hardened, load-bearing solid. This is the setting and hardening mechanism of gypsum. Now that we understand the mechanism, let's focus on the 7 key characteristics of gypsum, which directly determine its applications. 1. Extremely rapid setting and hardening. Gypsum is a fast-reacting material. Its initial setting time is typically no earlier than 3 minutes, and its final setting time is no later than 30 minutes. This is why gypsum is used in orthopedics departments to immobilize fractures. It can take shape very quickly. 2. High porosity and relatively low strength. The amount of water added during mixing is much greater than what is required for the chemical reaction. After the excess water evaporates, a large number of pores remain. With more pores, the effective load-bearing area is reduced, resulting in lower strength. 3. Lightweight, thermal insulation, and sound absorption. These abundant pores also bring advantages. Air is a poor conductor of heat and sound. As a result, gypsum boards are excellent lightweight materials with good thermal insulation and sound-absorbing properties. 4. Good fire resistance. Gypsum contains 2 molecules of crystallization water. When exposed to high temperatures during a fire, this water is released and evaporates, absorbing a significant amount of heat and acting like a built-in fire extinguisher to slow the spread of the fire. 5. Slight volume expansion during hardening. This is one of gypsum's most distinctive advantages. While lime shrinks and cracks as it hardens, gypsum expands by about 1% in volume. This allows it to precisely fill every corner of a mold without cracking, making it especially suitable for producing intricate decorative elements. 6. Breathing capability. Gypsum can regulate indoor humidity. It absorbs moisture when the environment is humid and releases it when the air is dry, helping maintain a more comfortable indoor environment. 7. Good machinability after hardening. The hardened gypsum can be easily processed by sawing, nailing, and planing. Next, let's look at the quality grades of gypsum. Unlike lime, which is classified using terms such as premium grade and first grade, building gypsum is graded numerically into 3 levels: 3.0, 2.0, and 1.6. What do these numbers represent? Remember, they directly correspond to the 2-hour flexural strength of gypsum, measured in megapascal. For example, a grade of 3.0 means that its 2-hour flexural strength must be at least 3.0 megapascals. In addition to strength, setting time is also a key performance indicator. The initial setting time of gypsum is no earlier than 3 minutes, and the final setting time is no later than 30 minutes. The applications of building gypsum can be broadly divided into 2 categories. First, basic applications. The most common uses include interior plastering and finishing, as well as the production of gypsum boards, gypsum moldings, and similar products. Second, high-end applications. GRG, glass fiber reinforced gypsum. As the name suggests, this material incorporates specialized glass fibers into gypsum. It is lightweight yet strong and can be formed into a wide variety of curved shapes. As a result, it is widely used in high-end venues such as opera houses and convention centers. Let's look at a painful lesson from real-world practice. In one project, plastering gypsum was used on exterior walls, and after 6 months, large areas detached and fell off. This is a classic example of using a material in the wrong application. Gypsum is a non-hydraulic material with very poor water resistance, and it must never be used on exterior walls exposed to wind and rain. In addition, take some time after class to reflect and discuss the following question. As a new type of wall material, how can the functional properties of gypsum, such as sound absorption, humidity regulation, and thermal insulation, be effectively ensured in practical applications? Finally, let's return to the question raised at the beginning of the lesson. As non-hydraulic cementitious materials, what are the differences between gypsum and lime? There are 3 main distinctions. First, the hardening mechanism determines the speed. Building gypsum hardens primarily through crystallization alone, a simple and direct process that results in rapid setting and hardening. In contrast, the hardening of building lime, slaked lime, relies not only on crystallization, but also on a slow carbonation process, which makes its hardening much slower. Second, volume change determines the application. This is the most critical difference. Gypsum undergoes slight expansion during hardening, allowing it to perfectly capture mold details without cracking. Therefore, it is naturally suited for decorative products. Lime behaves in the opposite way. It shrinks as it hardens, and shrinkage leads to cracking. Therefore, it is not suitable for fine detailing and is mainly used for general masonry and plastering. Third, the fundamental chemical nature differs. Although their raw materials are different, gypsum from gypsum ore and lime from limestone, their chemical nature is distinct. Gypsum is a sulfate, while lime exists as an oxide or hydroxide. In this lesson, we have learned about building gypsum. which is fast-setting, slightly expansive, and fire-resistant, yet susceptible to water. If lime can be seen as a slow and steady old craftsman, then gypsum is a decisive and efficient artist. There is no perfect material in the world, only the most suitable application. It is hoped that you will not only remember these parameters, but also develop a deeper understanding of material characteristics, learning to leverage their strengths, avoid their weaknesses, and integrate the steadiness of craftsmanship with the flexibility of artistry in engineering practice. In the next lesson, we will turn our attention to a special type of liquid cementitious material, water glass. What remarkable properties does it possess? See you in the next lecture. Thank you, everyone.